Hey, and what's up, everybody? Welcome back to another Nemotron Labs live stream. We're going to kick straight into the demo today, show you guys what we're going to actually build, what we're going to spend our time constructing. And for that, I'm going to pass you over to Edward, who's going to take us through what the end goal is today.
Hey folks, my name's Edward. Thanks for joining us today. Today's going to be a really exciting day because we're going to build a RAG agent together. So let me just really quickly show you what the end goal of that looks like. Let me zoom in real quick. You can see here I've got a chat client open right now with my RAG agent, and today we're going to build an IT help desk agent. So this means we can send it any IT related query we want, and it should be able to draw from a knowledge base and give us some really high quality responses. So for example, let's say I've lost my password. Let me ask this agent, how do I reset my password? So I can send it the query. It's going to go off and think for a bit, and then hopefully give me back a response. So you can see the response I get back, answers my question. It's really specific, and it's really grounded to the IT knowledge base that we've sent in. And we can see just real quick, some of the agentic reasoning capabilities that we've built into this agent. The ability to plan, call different tools out there, the ability to draw from this knowledge base, full of specific instructions, and the ability to ultimately reason behind a lot of the retrieved documents and be able to generate high quality responses. So this is the end goal. This is what we are working towards over the course of today, and by the end of this workshop, you'll be able to create your very own IT help desk agent.
So it's not just RAG, Edward. It's RAG with agents, right? That's exciting.
That's right.
All right, we'll get into it. We'll throw up some intro slides just so you guys know who you're looking at here. So my name is Chris, and we've got with us. You already said who you were, but one more time for the people just tuning in.
Sure. Yeah. Hey, my name's Edward. I'm a technical marketing engineer here at NVIDIA.
Heck yeah! And so what we're gonna do is work through how to build what you just saw Edward demo. And so for that, Edward, please take us away and show us how we get started building this thing.
Sure thing. Cool. So basically, the workshop that we'll be running through today is this launchable right here. You can see we've provisioned our instance, built our VM, completed our setup. Then all you have to do is just click this Open Notebook button, and that should take you out to this Jupyter Lab environment.
And
Now, if you were
Edward, for
here,
those of us
Mhm.
who don't know what a launchable is, what's a launchable doing here? How is this helping us?
Sure. A launchable is basically our way of packaging up both the hardware and the software into a single environment, and it's a one-click deployable link that you can use to set up your own development environment. It's pretty cool.
Awesome.
Cool. And if you were with us here last week, this might look a bit familiar actually, because this first tile right here is that build a report generator agent that we talked about from the last workshop, the last live stream. And so this week, we're going to focus on this second tile right here, which is building out your own RAG agent. So if I click into that, that should open up the instructions for me. You'll see we're going to create our own IT help desk agent today. And then by the end of this workshop, hopefully we'll get a better understanding of what Agentic RAG is and how it differs from traditional RAG that you may have seen already. Cool. So let's go ahead and dive right in. I do want to level set a bit with some basic concepts, right? Just so that we all have a clear idea of what agentic RAG is. So let's backtrack all the way back to LLM inference, basic LLM inference. Basically, what happens is a user will provide a prompt that will get fed through an LLM, and then we get out a response. And this response usually is generally pretty good quality. It's based off of all the pre-trained data that the LLM has already been trained on. But you do run into some, obstacles, with this type of inference, right? So, for example, you might run into hallucinations. You might run into, since the LLM's pre-trained up to a certain date, you might get some good responses, for everything before that date, but everything after that date, you might get lesser quality responses. And so, we really try to fix that with what we call RAG, or retrieval augmented generation. And so, this is really where we introduce a sort of retrieval in our own vector database into this into this diagram right here, right? So for example, I might have my own data that I want to feed into the LLM as context. And so I'll be able to, embed that, store that properly, and then every time, a user submits a prompt, I can retrieve out the most relevant data to the LLM to use as context and hopefully get out a better and more grounded response. Now, this usually works pretty well. You get out, better, more grounded responses, but you also might run into issues with traditional RAG, right? So, for example, your RAG is only as good as the data that you embed into the vector database. And so, if you have poor quality data in that database, you might get out poor quality responses as a result. And this workflow is a static workflow, right? So every single call, you're going through the same exact workflow. It's not really dynamic, and so that's really an opportunity for us to introduce agents into this workflow, right? So what agents can do is it can bring in tool calling capabilities where you can go out to multiple different sources and not just one source. For example, if you don't find a right source in your vector database, maybe you can call a tool to go out into, do some web search and get out results from the web. Agents also provide reasoning capabilities. So, this allows us to, make a plan, iterate on that plan, repeatedly, and then get out, much higher quality responses that way as well. So this is what our React, in this case, we're using a React agent architecture. This just stands for reasoning plus action, right? So you can see this iterative loop that we take with every React agent where a prompt gets fed into the reasoning LLM, and then we're able to repeatedly call out the tools if we need to build out our response. And then once the agent is happy with the response, it'll get fed back out to the end user. And that's how we can ensure that, the response, actually answers a question, is well grounded, things like that. And so
And
when we
Edward,
put, Mhm.
just to ask a question that's on my mind right now. I keep hearing on social media that like RAG is dead. So why are we still doing RAG here? Like, what's the I get we're boosting it up with agents, but like I thought it was dead. What's the point of it?
RAG is dead. Oh no. No, I think RAG is very important actually. I mean, a lot of the for example, if you go out to like Perplexity or if you go out to even with Google searches now with AI overviews, like a lot of what they do is they retrieve sources from the web, from all these different databases, and that way, you can feed in those sources as context to the LLM, and that way, the LLMs, pre-training alone can get you so far. But, for example, like I said earlier, pre-training cuts off at a certain date, right? And so if you ever want real-time information, if you ever want, information that you might not find anywhere else, if you have private data sets, for example, that you can't find on the web, then you'll want to utilize RAG to be able to draw out that information as context for your LLM to augment its knowledge, basically. And so that's why RAG is important.
So it seems like it's probably still alive then. We don't have to have the funeral just yet. And we've had a couple people asking Edward, so I just want to make sure they know. Guys, the recording will be available afterwards. So you can watch this afterward. And also, all of our previous streams are recorded as well. So you can go back and watch those through whatever channel you most prefer. So don't worry, it's recorded, and we will. You can go back in time and watch the ones we did previously. Thanks, Edward. Go ahead.
Cool. Yeah, great questions. If you ever have any questions, feel free to drop them into the chat, and we'll have a question answering session. Cool. So putting everything together, right? So we have our React agent that we just went over, and then we have tool calling, right? So what we're going to do today is we're going to build out this retrieval chain, and then we're going to attach that to our RAG agent, such that that RAG agent can utilize this tool to help it generate the responses that we want it to. Cool. So with that said, let's go ahead and build out our agent. So first thing is you want to be able to set up all your secrets. We include this pretty nifty secrets manager as part of this workshop to put in your API keys. I know this looks overwhelming, but really for this workshop, all you really need to do is set this NVIDIA API key right here, which you can find on build.nvidia.com, as well as NGC. If you've joined us for the previous workshop, you can see like the OpenRouter and Tavili API keys. We don't need them for this workshop, but we use them in the previous live stream. And then Langsmith is an optional key that you can use to help monitor and trace your AI application. Cool. So I've already set that up. And what we can do now is actually go through this build an agentic RAG section right here. So our entire RAG agent is contained inside of this RAG agent.py file um, right here. And then we can just go through side by side, go through the major components of this RAG agent that we're going to build. So first off is the actual configuration and setup steps. And so you can see here we've loaded in our data, and then we define things like our model. So in this case, we're using the NVIDIA Nemotron Nano 9B V2 model. This is part of the NVIDIA Nemotron model family, which is an open model family with open data, open weights. And it's a really capable, lightweight reasoning model. So it's going to help us accomplish exactly what we need it to accomplish. Next up, we're going to ingest our documents into the vector database, right? So in this case, we're going to use this in-memory face database. And in order to do that, we'll have to take all of our documents, chunk them into smaller sections, embed each of these chunks into vector representations, and then insert these vectors into the vector database. And so you can see the workshop will walk you step by step through how to do exactly that. And then here on the right, I've already implemented what that looks like, right? So we're splitting up our documents into chunks. We're using our NVIDIA embedding model to help embed each of these chunks into vector representation. And then we're going to create our vector database based off of each of those documents. And so, these steps will help us ingest all of our documents into the vector database for us to retrieve from and use later down the road. Cool. So once we've ingested all of our vectors, the next step is to create our retrieval chain tool. So if you remember from the last workshop, we just used a pre-existing tool, the Taviliate Search API. In this case, we're actually building out our own tool and feeding it into the RAG agent. So to do that, we need to build out our retrieval chain. This right here just demonstrates what a simple retrieval chain looks like, right? So it's basically an embedding model. Inputs are fed into this embedding model, converted to vectors, and then stored into this vector database, and then retrieved from that database. What we're going to do is we're going to add an extra layer to that through this re-ranking model. And so this re-ranking model basically takes the outputs from our vector database and re-ranks them based off of a relevancy score. So the more relevant documents are sort of prioritized, and then the lesser relevant documents are not as prioritized. And that way we can have more control and have more sort of be able to control for the response a lot better. So this is what we're sort of doing here on the right. We're defining our retriever, and then we're creating our retriever tool based off of our retriever and our re-ranker right here, and giving it some metadata. And so this is what that end retrieval chain looks like right here. Cool. And then at that point, we've defined our tools. We're now ready to create the actual agent itself. So moving on here in this step, we're going to create our agents. The most important thing we have to do is define the model that we want to use, right? So at the end of the day, the model is what is the brains of our agent, right? And so it's what's going to be used for our decision making and thinking, reasoning processes. So in our case, we're going to be using what I said before with Nemotron 9BV2. And that model, because it's a reasoning model, it's going to give us a lot of that thinking capability and tool calling capability that we're looking for out of our agent. And so we've defined that right here. We also have a system prompt. This is going to help guide our model into exactly what we want it to do, right? So we're telling it, hey, you're an IT help desk agent. Here are all the tools available to you. Here's what I want you to do with every user request. And then keep things brief, to the point, etc. So the system prompt is always an important part as well. It's not just the model, but it's also the prompt to help guide the model. Cool. And finally, we're going to wrap all of these components that we've built, the vector database, the retrieval chain, and the model. We're going to bring all these components together into an actual LangGraph graph. And so LangGraph helps us provide sort of the agentic framework for basically creating a flow chart, right? Basically telling our agent, what paths to take under which circumstances. And so we do that here at the end, where we bring in all of the different components that we've defined, the LLM, the retriever, and the system prompt to create this React agent.
And
And once we're
Edward,
yep,
just to cut you off there, we had a question in chat that I thought was really great that I want to just kind of interrupt and answer now that we're talking about the actual, you said flow chart for LangGraph kind of thing. So there's a question in chat that talks about the difference between agents and workflows, right? So in simple terms, this is from Utkarsh. In simple terms, what's the difference between agents and workflows? I think this is a great time to answer this question.
Yeah, that's a great question, actually. So the way I like to think about it is agents have a certain degree of autonomy, right? Whereas workflows, we can sort of predefine workflows, we can automate workflows, but at the end of the day, they turn out to be static, right? So, for example, if you look at that traditional RAG diagram that I mentioned earlier, we see there's one specific defined static workflow throughout that every single user request has to go through. And so, that's great for certain tasks, but for other tasks where we want to bring in sort of a more dynamic and reasoning into it, I think that's where agents really shine. So with agents, basically, we give the agent autonomy to do its own thinking, its own iterative thought process. We give the agent, autonomy to take actions whenever it sees the need to. And so that way we get out just sort of a more dynamic. It's basically making your existing workflows a lot more dynamic, which is the whole goal of this workshop, is to make your traditional RAG workflows a lot more dynamic by introducing agents.
Yeah, and it's this idea that like they exist on a gradient, right? From like workflow to agent. And it's the amount of, quote unquote autonomy that you can give your system that allows us to kind of scale this gradient, right? So it's like a, hard and fast workflow on one side, fully agentic system on the other side. And you can build an application that sits anywhere between the two. And that allows you to use this kind of flexible implementation where it's needed. Like, for instance, in this example that Edward's showing us, we still have some guts of it that are very workflowy, right? But the total system together is more agentic. And then before we move on to the rest of the tutorial, I wanted to have one more question that we talk about. VK asks, what is NVIDIA embedding model significance? What's the significance of the NVIDIA embedding model?
Yeah, that's a great question. So embedding models, just in general, help you convert basically text information into vector representations. So so I guess the broader question is like, why do we need things converted into vectors, right? So in this case, if we go back to our architecture diagram, why do we need to convert things into vectors? Basically, with vectors are just mathematical representations, right? They're just, a string of numbers, basically. And we do that because it helps us do our similarity search a lot more easily, right? So for example, if I have a user prompt come in, I want to embed that as well into a vector representation, and that way I can compare that vector to other vectors that I've already stored in my database and do that similarity search and find out the closest vectors to the user query, and then that way I know for a fact, hey, these documents sort of are the closest or the most related to the user query, and so I can retrieve those and give them to my agents to handle. And so that's why embedding models are really important, because it allows us to do that comparison between natural language queries and the documents that we've already embedded and uploaded into our vector database.
And there's some like idea that a better embedding model means that you're going to more reliably get better similarity scores, which means you're going to more reliably retrieve the correct, quote unquote, correct chunks, right? And so that's why
Correct.
we're using this particular embedding model, is because it's quite good. It also has a very long context, though we're not taking advantage of it here. And what that means is that even if you have longer paragraphs of information, we can still get like really high quality embeddings out of those. And so it's just a good model to use, which is why we've selected it for this use case. Anyway, Edward, we'll carry on with the rest of the tutorial here, and we'll get to all of the awesome questions we have in the chat afterwards. Guys, please keep asking questions. We've got a ton. I can't wait to get to them.
Yeah, absolutely. Cool. At this point, we've basically just built our agent, right? And so all we need to do now is figure out how to run this agent. And thankfully, that's pretty easy. All I have to do is run this command right here, and this will set up basically an API server. And so I'm basically going to have this agent running behind an API, and that way, if I have different chat clients, I can connect to this API and basically be able to use the agent that way. So I've actually already done this at the top of the hour. This is the demo that you saw at the very beginning. I've run this command here. This basically spins up this server backend, and then I've connected to it with this front end right here. And once again, you can see, where the agentic reasoning comes in. The planning stage. Basically, the agent's going to come up with a plan to help best address this user query. It's going to actually, call out to different tools like this, company IT sort of knowledge base right here. It's going to be able to retrieve all this information to feed it back to the agent, and the agent's basically going to reason about this information that it just retrieved, and then come up with the best response based off of that. And so this is the final response it gave back. You can see, contrary to traditional RAG or even just regular LLM inference, you can see that the response is very specific. It's not general. It actually answers a question. It doesn't hallucinate, things like that. And so that's what we can help ensure by adding agents to our existing RAG systems. Cool.
Hi. Yes, and one last question before we get to the questions we've got in the chat, Edward, that I have. This is dope. I love that we're running it in this launchable. That's cool. I love that we're using these endpoints. That's dope. But what if I want to run it on my own hardware? Do we have a path for that?
That's an excellent question. So yeah, you bring up a great point. This workshop right now utilizes the NVIDIA hosted endpoints, which are great for development, prototyping, testing use cases. But a lot of the times, once you're finished building your application, you want to actually move it into deployment. You want to be able to use your own, locally hosted model endpoints instead of ones hosted by NVIDIA. And so this is where this section comes in, where we get to basically walk you through step by step how easy it is to migrate everything to use locally running NIMs. To do that, I won't go through the full process here, but basically you're going to want to spin up your own NVIDIA Nemotron Nano 9B model running locally. This is running with NVIDIA NIM. And then once this container is running locally, you can just swap out that endpoint that we're using, right? And so it's basically a really simple code change. You really only need to change one line. Basically, previously we were pointing to the chat NVIDIA endpoint, which by default uses the build.nvidia.com endpoints. But since we've spun up our own locally running Nemotron model, and if we want to use that, all we have to do is do this code swap. This line of code right here, where instead of pointing to builds, we now point to this locally running model endpoint. And once you do that, you should be set. You should be good to go. And then you should be able to still use that agent, this time using a local model instead of using models hosted in the cloud. Cool.
And that's how easy
it's really
it
easy.
is.
It's a really easy swap for sure.
Download NIM, run NIM, change address. Hey, that's not so bad. Let's get some questions from the chat. We've got a lot, guys. Keep them coming. It's dope to have so many questions. There's a lot of questions coming up about how do I access the workshop, which is going to be available in the chat. We'll drop a link to it. And questions about recording. This is being recorded. You can visit our YouTube channel in order to get those recordings, or whatever service you're watching this on. LinkedIn and X will also have those past recordings. So those ones we'll get out of the way quickly. And then we have a bunch of great questions that we're going to start talking about. So VK asks, is Elastic the most friendly vector DB that has the advantage of storing the embeddings? Edward, most friendly.
Most friendly. Most friendly, I feel like is a subjective term, but has the advantage of storing the embeddings. I would say, essentially any vector database that you use will be able to store those embeddings well, right? So you know, a lot of the one that we're using for this workshop is called FAISS. It's FAISS. Basically, it's a vector storage that is stored in memory. So it's really lightweight, really easy to spin up really quickly. And then once you move into you know, more production use cases where you actually need something more robust, you can always switch to different you know, vector database providers. So Elastic could be one. I know Milvus is also a popular one. Popular use case because you know, you're able to, you know, use GPU acceleration as part of the Milvus vector database, and there's a bunch of other ones out there, honestly, that you could use, like you know, LanceDB, Chroma, you know, quite a few options out there. And so, you know, you really need to think about which use case that you know, you're building towards, and think about which vector database is best fit towards that use case. So yeah, great question.
Excellent. Couldn't have said it better myself. There's many. Pick the best one for your use case. We have another question, which is pretty interesting, from Juan Alberto, which is going to be, how do you guard against prompt poisoning in multimodal agents? Or probably more specifically, you know, how do you guard against prompt poisoning generally? And one answer that we have, of course, out of the box is good old-fashioned Nemo guardrails, which is a microservice that we've produced that does exactly this kind of work. You know, so that's going to be like the sledgehammer solution. Edward, what do you think, just from what we saw today? What are some ways that you may consider some, you know, outside of going full swing into something like guardrails, right? What are some things you might consider to help defend against people being tricky with their prompts?
Sure, yeah. That's a great question. I think, you know, guardrails is a great solution. I think, let's see, you could also, you know, do more granular, I guess, guardrails where, you know, maybe in the system prompt, for example, like you'll say, hey, you know, make sure that, you know, you're not doing anything malicious. Make sure that, you know, the answers that you respond, make sure maybe you include a step where it's like, oh, evaluate the question or evaluate the prompt to make sure it's not malicious. It's not, you know, going to poison anything. And if so, you know, maybe we have like a cutoff or something where we just say, hey, I'm sorry, I can't answer this prompt. So a few different ways to go about it, you know, more granular solutions like that. You can also go with what Chris was saying with the Nemo guardrails. I think that's a great solution. Basically, just whatever output that the model is thinking of, you know, we run it through sort of a filtering process with guardrails to make sure that, you know, everything is up to par and nothing's gonna, you know, do anything malicious to you. So, so yeah, great question.
Awesome. Okay, we got another question from Farhan, and this one is, will the RAG agent built here be deployable for production workloads? This is a great question. What's your thoughts, Edward? Are we taking this straight into production?
Yeah, that's a good question. So as it stands, I would say this is more of a learning and development type of application. So, like I mentioned earlier, we're using components here that are, you know, more geared towards like a development type of use case, right? So, for example, we're using API endpoints right now. If you ever wanted to move into production, you can consider, you know, changing the code a bit. You know, really just that one line of code where you can bring in your own locally running NIMs, NIMs running on-prem, and, you know, be able to use your models that way. The vector database we're using is also, you know, a very lightweight, in-memory, quick to spin up database. And so if you wanted to move towards something, you know, more robust, you can also consider swapping that out as well. But in general, it should be fairly easy to do each of these swaps. But yeah, so as it stands right now, it's mostly a tool for us to learn how to build a RAG agent. And then if we're actually thinking of moving things into production, we might have to, you know, change things up to be a bit more robust for that use case. So, but yeah, excellent question.
Yeah, and I think this is something that's important to double click on, right? Like the agent itself, the composition of like the code, the line graph, right, isn't the thing that needs to change. We just want to service those components with production ready, you know, backends. So it is very easy to move to say the meme from prototype to production with this setup, which is perhaps the most important. We're gonna keep answering questions, guys. You got a lot. We're gonna stick around and answer them. However, we want to make sure that you guys know how you can keep in touch with us if you have questions down the road, if you want to get engaged in the community. And so we're gonna do the community slides now, and then we'll go right back to QA. So if we can get those up, first of all, you can join us, of course, at build.nvidia.com. This is where all of our models live that you can play with. So this includes like the Nano V2 that you saw today in the demo, and the embedding models. You can play with them through the UI, but it's a bit less fun. But they're hosted. We also, of course, have our Discord, discord.gg/NVIDIA developer, where you can come in and ask any questions you have. We have a hashtag Nemotron-models channel, and we love to get you in there asking any questions. We stay patrolling that Discord so that we can answer those questions as they come up. And then finally, we have one more slide, I believe, which is that you can just email us, community@nvidia.com. If you still like emailing people, please email us your questions, suggestions, whatever it is. We're trying to build a community here about this Nemotron Labs series. So please keep in touch with us. Hit us up on LinkedIn, either of us, Edward or myself, of course. More than happy to chit chat. And then finally, last but certainly not least, GTC DC is coming up at the end of October. That's right. Come on down. I'll be there. Come hang out in DC, have a chat, do some cool stuff. Learn about how this whole AI thing's kind of catching on. So that'll be a blast. Thanks for bearing with us through the community section. We want you guys to feel like it's not just Tuesdays that you can talk to us. So we'll move on to the rest of these amazing questions now. This is the next question that we were going to talk about is by Error 404. Great name. How the chunk size affects the RAG model. This is a classic question. We get it a lot. Edward, how important is chunk size to our agentic RAG pipeline? How much should we be fretting about that?
Yeah, that's a great question. So actually, if we look back in the code here, let's see. We can see we define our chunk sizes here as at the top, right? So there's both chunk size and then there's also chunk overlap, right? So chunk size is basically, how big do I want each of the chunks? I want the chunks to be big enough to have relevant information contained within them, but also don't want them to be too big where, it maybe takes forever to process, for example. Chunk overlap is interesting as well because basically it just tells us how many, tokens do we want two subsequent chunks to overlap with each other. And that's good because, we're able to get out sort of that contextual information from the chunks that are surrounding a particular chunk too. And that could be important in helping, maintain, broader context and help, the agent understand what's going on around a particular retrieve chunk. So both of these are important, and you do want to make sure you choose, chunk sizes and chunk overlaps that aren't too big or aren't too small, but are sort of just right to help, provide that optimal performance from your agent. So excellent question.
And something that's important, guys, is like this is like a hyperparameter, right? So this is something that you can tune for your use case. It's very dependent on the data that you have in your vector store, and so it's not like we can just say, oh, you should use 800, or like, oh, you should use 967. It's going to be something you can tune for your use case, and we've got tools to help you tune that, of course, through things like Neo Agent Toolkit, but. The idea is that this is not going to be a one size fits all. This still requires you to look at your data, to again say some memes, but it is important. The next question we're going to look at is Laura Santa Cruz. What does the re-ranking model specifically do? Why not retrieve from the database according to cosine similarity? Excellent question, Edward. What's this whole re-ranking thing? Why are we bothering with that?
Yeah, that's a good question. So basically the re-ranking model, basically whenever you retrieve data out from your vector database, all it's doing is it's finding information that's, where the embeddings are the closest to the embeddings of the input user prompt. And so, basically it's just basically finding that mathematical similarity. But once we convert all that back into natural language, you might get some variation there, right? For example, maybe I ask it a question on a certain subject. The retrieved documents, mention a lot about that subject, but it doesn't really have anything that's relevant or useful. Or maybe it's mentioning that in a completely different context that I didn't think about at first. May not be as relevant. And so if we add in this re-ranking layer, we're able to re-rank each of these retrieved documents that are closest around my user prompt in a way that's more informative for my agent or for my model to use. Maybe if something mentions a particular word a lot of times, but it's not relevant, maybe that'll get re-ranked to be lower, even though the actual similarity score might be closer. So you can think of situations like that where that might arise. But yeah, great question.
Yeah, and I think it's one of those things where, like, we want to be able to do it. We're going to have lots of documents, so we want to be able to search them fast, right? Like, latency is a really huge consideration. But in order to get fast, we have to give up something, and it's usually quality, right? And so the idea with that re-ranker of being able to pare down from fast, big, expansive search to to like an actual slower, more labor intensive search, right? For the second step, lets us kind of have our cake and eat it too a little bit, which is real nice. We'll go to the next question. This is one of my favorite questions. This is from LinkedIn user. Sorry, I can't see your name. What's a reasoning model? How is it different from other models? What's thinking? Is it comparing multiple answers? So reasoning models are, I'm just going to say the words in the opposite order, models that can reason. And what this really means is that they have built-in chain of thought reasoning in these thinking tags. And so instead of just going from your query to the final answer, they actually go through this process of generating a lot of tokens. And those tokens are meant to guide and inform the final response. So in basic terms, it's a model that produces more tokens to think better. So that's how it's different from other models, and that's hopefully what thinking is. It's not comparing multiple answers strictly, though. So it's not like we're producing 7 different responses and then checking them, though in the course of thinking, the model may consider multiple answers. It's not like that's a scaffolding that is like a best of n, where it's going to actually look at 7 different answers and choose the best one. It's more so going to think through just like a person would, right? Step by step through the problem, land at different conclusions, ask questions about those conclusions, and then carry on to the final response. And the reason it's so good here is because it allows the model to make those kind of second order jumps, right? So we know in RAG, Edward and I know very well that this idea of like multi-hop QA is a lot harder to do, because you have to think through how many different pieces of information interact, right? And that reasoning model is quite good at it. Anything you want to add there, Eric? Or Edward, sorry, Edward, my bad. Edward, anything you want to add?
No, I think you covered it well. I think reasoning models are basically the next step. Just taking a step back, reasoning models are the next step for traditional models, right? So you're able to incorporate that reasoning, that chain of thought process, to help guide the model down towards more accurate or better quality responses. And what that enables us to do is, because it can reason or think, it can also plan things out, right? And that's where sort of the action component comes in as well. So, maybe, for example, in this workshop that we've built here, the model is going to think through all the actions it needs to take in order to best address the user query, and then it can, choose to go out and do various tool calls, reason on the results that it gathers from those tool calls, things like that. And all these capabilities, a traditional LLM would not be able to do. A traditional LLM is very much, you give it a prompt, it'll give back a response in a single shot. So yeah, I think it's a more powerful class of models essentially.
Yes, and this lines up very good with the comment that hopefully we can put up on screen from Emre. It might be a bit of out of scope, but when choosing the model, when decided between reasoning and instruct models, is it fair to think of it this way? Reasoning models are better suited when the agent is interfacing directly with people, handling ambiguity and complex decision making, while instruct models are a stronger fit when the focus is on automation, structured tasks, or repetitive workflows. I think minus the interacting with people, both are good at interacting with people. This is absolutely an excellent way to think about the difference between the two models. When we're going for automation execution mode, Instruct models are amazing. When we're in the ambiguity, planning, reasoning space where there's not just one task that needs doing, reasoning models are going to be a huge boon. We have the next question here, which is going to be from Sandmeet Carr. Can we integrate clip model alongside RAG with agents? This is kind of like a leading question for you, Edward. And more so, I'm going to ask you: Can we make this work with pictures? Because it's working good with text. Is there a way that we can make this work good with pictures?
Yeah, absolutely. It's a great question. I think a lot of what we're building here is sort of setting like a baseline or a reference implementation for you guys. But you guys can always take this workshop and build on top of it, extend different functionality that you want to see. And so I think incorporating images with a clip model, for example, is an excellent way of extending this workshop to additional functionality. So yeah, I think a lot of the RAG systems that you see today, for example, on Perplexity or maybe in Cursor, like you're able to upload your own images as well and have sort of the agent reason through that as well using models like the clip model. So yeah, I think it's absolutely a compelling use case to utilize images alongside text in each of your RAG systems.
Yes, I see a lot of questions about RPMs, and I just want to clarify for people that's just requests per minute, so that's a rate limit. That's all it means. It's specific to the endpoint. If you're using the local development, your RPM is going to be determined by your hardware. Okay, the next question that I want us to talk about is from Makul Yadav, who says, "What would be the right way or workflow to evaluate an agentic RAG system?" So we've built this RAG, we've built our IT support desk helper. It's out there in the wild, crushing it. How do we determine if it's like doing a good job, or how do we know even before we deploy it? How can we get a sense for if it's doing a good job or not?
Yeah, that's an excellent question. I think evaluation is a super important part for us to be able to understand how well our RAG system does, right? So for that, we do have a few different options. I think the most prevalent one right now is Nemo Agent Toolkit. It's like an additional toolkit that developers can use to help evaluate their agents' performance on a variety of different tasks. So for example, with this RAG agent, you're able to evaluate maybe how grounded the responses are to the retrieved documents. You can maybe evaluate the accuracy of the final answer. There's a variety of these different metrics that you can use. And then once you evaluate your RAG system, you can see sort of where the gaps are, maybe where your RAG system does well, and be able to make different design choices, maybe swapping out, this embedding model for that embedding model, for example, and see how that affects your performance. And so that way you can gradually build up to something that matches the performance level that you're looking for. So yeah, so evaluation is definitely a key component for helping us build out these agentic RAG systems.
And of course, I got to stump it, right? We have Nemo Evaluator Microservice, which has agentic RAG or has RAG workflows out of the box, powered by those good guys there at Ragus. So there you go. If you want to read more, you can start there. Okay. The next question I want to talk about is from Ken_dev. One common challenge with RAG-based architectures is context poisoning. This can adversely affect the performance of the resulting agent by introducing bias, hallucination. How do you handle this? So this is one thing that I'm going to say off the bat before we hear from Edward is it is so RAG is meant to ground responses, and grounding is in some sense helpful to mitigate hallucination, right? So this is the idea of RAG. It's not just for getting rid of quote unquote hallucinations, but it helps, right? It can help smooth out those instances. However, something like context poisoning, which is where we actually have undesired chunks or of context in our RAG pipeline, right, is gonna have the opposite effect. So how can we mitigate this, right, Edward, when we're building our RAG system? Like, how do we avoid this idea that while RAG is used for grounding, if we have poisonous chunks, it's actually going to do the opposite to us, and it's going to hurt us and degrade the quality of our generation. So how do you approach handling this?
Yeah, that's an excellent question. I think so. First off, before we dive into it, I think the quality of your data is always going to be important. So we should always strive to have high quality data in any data source that we're using, right? But in cases where we can't avoid that, there are a few different ways. Um, so, for example, maybe I know some of the other work that I've been doing on the deep research side, we have something similar going on where we have this agent that can go through a variety of different data sources, right? And so that way we can maybe build in some redundancy. Maybe we have a poisonous chunk in one database, but then maybe the RAG agent gets additional chunks from these other databases, and it's able to sort of reason, hey, this one chunk is maybe a bit of an outlier. Maybe I'll just go with everything else that I'm seeing from these other sources. Maybe it'll go to the web, and then as well. Basically, building in redundancy into your agentic RAG system is always helpful in helping to mitigate these one-off situations where maybe you'll run into like a poisonous chunk, and then maybe we can get the agent, because of the reasoning capabilities, it can evaluate all these retrieved chunks and be able to say maybe, hey, this chunk maybe isn't as relevant, but all of these other sources are saying this other thing. Maybe I'll just go with that consensus. And so that's one example of one way that you can potentially mitigate these poisonous contexts. So that's an excellent question.
That's exactly it, right? Like, what does it come down to? We need to care deeply about our data, and we need to have guardrails set up in place to help us. Something like the re-ranking is already helping with this in some sense, right? So but there's an endless number of steps that you can take to continue to make this better. We're going to keep chugging for a little bit, guys, and because you guys just keep asking awesome questions, which is dope. So thank you. In the case of Charles asks, in the case of NIM, how do we customize knowledge databases? So this is interesting. So this question is an opportunity for clarification, right? And it is, the NIM itself is not going to hold the knowledge database. It's going to be used to construct it. And so actually, when we build RAG, we have the ability to customize the knowledge database through whatever means necessary, right? And whatever means we have. But NIM itself doesn't add any kind of limitation to customizing knowledge databases other than it is going to be an embedding model, for instance. And so you're going to want to continue to use that embedding model. And if you wanted to use a different one, you'd have to spin up a new NIM. Edward, anything that you'd want to add here?
No, I mean, I think you hit the nail on the head, right? So what NVIDIA NIMs provide are those models surrounding your database, right? So like the embedding model and the re-ranking model, both on the ingestion and retrieval side. But the model, or sorry, the knowledge base itself, the database itself, is ultimately going to come down to like a design choice based off of whatever use case that you're pursuing. But NVIDIA basically just accelerates everything around that basically, and it can even accelerate your actual knowledge database through something like kubeS. But yeah, so that's how we sort of that's how you are able to sort of control for these vector databases or these knowledge databases using NIM.
Yeah, and something that we've had a lot of questions, so we don't have one specific one to throw up on the screen, but a lot of questions about well, does this work with XYZ vector DB? Is this good with XYZ vector DB? And the answer is LangGraph, which is the kind of framework that's being used, has connectors for tons of vector DBs, including all of your favorite ones. As well, you can spin up new ones relatively simply, especially now thanks to AI-assisted development. And so it does work with whatever your vector DB is, because that's an independent service to the actual agent pipeline. That's kind of the beautiful thing about constructing agents in 2025, right? All of these microservices that we're tying together live in their own house, right? You can use Pinecone, which lives on Pinecone servers. You can use Quadrant and spin it up yourself. You can use Milvus wherever it's hosted, right? The idea is that you're going to adapt or connect that resource to the rest of your agent pipeline. And so, it'll work with whatever you have a connector for, and you can write custom connectors, means it'll work with basically anything. Now, the question, is it good? Is it the best for my use case, is going to be a question you're going to need to really look at. What kind of volume of data you have? What are your embeddings look like? What are you looking for in terms of vector DB performance? So that's going to be a more involved process than just plug it in. There you go. Okay, Edward, anything to add on that?
No, I think we're good.
Heck yeah. Okay. What model? Jason asked, what model is used to do the re-ranking? You better believe that that's the Llama NV re-rank model. So it's in the workshop that Edward put together. If you want to show us that one more time, there it is. NVIDIA Llama 3.2 NV re-rank QA 1BV2 is the full name if you want to check it out at build.nvidia.com. There you go. Yes. Okay, this is going to be a bigger one, Edward. We're going to pause on this one for a bit. Samitro asks, can you talk about, and many others to be clear, but this is just the one we're going to highlight. Can you talk about security and identity management in the context of using agents?
Yeah, that is a big one. That's a great question. And I think, a lot of this, is really important, especially in the context of, an enterprise-based application, right? So, for example, maybe you have, a bunch of different data, a bunch of different enterprise data, and a bunch of different users, right? And certain users might, maybe you only want certain users to have access to certain, documents or certain data sources compared to other users. And this is where we can build in sort of an authentication process where, as a user, I get to authenticate into a particular role, and then the certain roles have certain visibility into different databases or different collections within a database, things like that. And so that's, right off the bat, that's one easy way you can utilize identity and security management in the context of using this particular RAG agent. And then, yeah, I think that's really the main use case that we're focused on right now. And a lot of the work that we've been doing, especially on the blueprint side, which are more geared for enterprise, utilize that sort of line of thinking where we want to be able to make it easy for enterprises to help partition their data into different identity roles, and then give users a particular role to access certain amount of data, because you don't want person A to access important financial documents if they don't work in the finance space, for example. So we want to be able to build in those security measures, especially in the context of agents, because agents are autonomous, and we want to help each agent sort of work in its own lane, right? So that's an excellent question. Anything to add, Chris?
Yeah, I mean, you hit the nail on the head, man. The only thing I would add is, like, agents are now part of our workforces, right? And because they're part of our workforces, it means we need to treat them like they're part of our workforces, which is means our IAMs have to evolve to consider the existence of these semi-autonomous, programs that we're running. So it becomes very similar to people resource management, right? And I think that's great and interesting. It's certainly one of the larger challenges, right? Because we already have to put a lot of trust in humans, right, when they're using systems, and this is no different with those agents. And so it is a big challenge. And as our behind the scenes legend that you may have seen answering questions in chat, Matt said, this is the number one kind of thing to fix before you take a demonstration like this into prod, is making sure that people have access to the right data, and only the right data. Let us let's do a few more. We got one from Samitro again. How does NVIDIA use KV caching to scale to high request volumes with minimal latency, and what are the practical limitations? So this is a in-depth answer that we're probably going to point you to existing resources for. Dynamo office hours, is a great place to talk about this. But what I want to focus on here is that there's a special relationship, right, between KV cache and something like RAG, right? Because RAG's all about filling up context. It's all about providing the right context for the right question at the right time, right? And KV caching is all about caching some of that context, right? So, Edward, any thoughts about kind of the interplay between KV caching and RAG? And how do you think about, leveraging the actual hardware and the inference pipeline to make our RAG stacks better?
Yeah, an excellent question. I think, yeah, KV caching is an important part because like it helps with the caching, right? So if I'm working on these much larger GPUs, for example, a lot of that VRAM will be allocated for the KV cache, and so that will help speed things up performance-wise, especially if I have a lot of volume incoming, right? So if I have a bunch of users trying to connect to my RAG agent, I want to be able to utilize that additional KV caching to help accelerate the processing of each of those requests at minimal latency, right? So traditionally, like you can think of there being sort of this trade-off between, if you have high volumes, typically, that'll lead to, higher latency. It might take a while for your thing to process, for your request to process. But, if we build in sort of that, especially that hardware layer where we can allocate all of this, KV cache to free up a lot of those resources, we should be able to help process high request volumes at a much lower latency, especially for all these incoming RAG requests. So yeah, I think KV caching is super important, sort of at sort of the lower layer in the stack, that enables this full stack acceleration that we're trying to aim for. So yeah, great question.
And that's the big point, right? And if you guys don't know what KV cache is, you're like, what the heck is KV cache? We've got tons of resources that you can read about it. But the big idea is that it's going to hold some of the computations we've already did in memory, so that we don't have to recompute. Recomputing takes time, and so it saves us time, just like any other caching. We're going to end on this final question, Edward. It's been an absolute blast today, and guys, please don't forget to join us in our Discord. Please, we'll keep the conversation rolling. Come on out, leave your questions, or in our developer forums. Both links on the screen right now. We'd love to chat with you guys. Go. Oh, one question. We're gonna answer very quickly. Can we shrink cost by adding cache in the first place? Also introduce compression of RAG responses from a small model first, and then send to large LLM. This is by Savik. The first thing you want to do when you have many users using your application is have some form of caching for their most asked questions, right? You're going to get this very fast, and doing this is going to make the user experience instantly much more pleasant. So the answer is yes, you can shrink cost by adding a cache. You have to do it smartly, okay? But you can, and it's very easy to do with LangGraph. They have built-in connectors for cache. Edward, any closing thoughts on that before we've got to spin the stream down here?
No, I think you're right. You can absolutely shrink costs. You just have to, like, the devil's in the details, right? So you just need to be able to figure out exactly, what the bottlenecks are in your particular workflow. This is a pretty technical question, and then be able to optimize for that, right? So if, for example, you need to add a cache to help reduce costs, we want to be able to implement that smartly. So yeah, great question, and I think we're all working towards shrinking costs as much as possible, right, in order to make these RAG agents even more accessible. So yeah, great question. Chris, back to you.
That's it, guys. Thank you so much for joining the stream today. It was an absolute blast. Loved all the questions. There was a ton. We'll have to get to answering some of the ones we missed a little bit later. But absolutely 10 out of 10. Thank you so much for joining us today. We will be here next Tuesday as well to answer questions. So it'll be office hours. So any that we didn't get to, we'll be sure to answer there. Edward, thank you so much for your time, your expertise, and that dope workshop. Guys, check out the workshop again. It's on GitHub. Take you soup to nuts on how to build that RAG agent. And yeah, hit us up on Discord, email, the forums. We'll see you guys in the next one.
Thanks, everyone. Have a great day.